Okay, I guess we should get started. I proposed this topic, but Andres has been the main developer of this, so he's also here. So I suppose we'll do this together. So I guess the concrete topic is here. There's a proposal in the Postgres development community to add support for the Meson build system. A patch has been floating around for about a year or so now. Is that about right? About a year?
I don't honestly quite remember.
It's been a while. Oh, yeah.
Yeah.
So
it's been in development that much long.
We're getting to a point where this is something that could actually happen in the Postgres 16 cycle. The patch is registered in the commit fest for July, so you can find it there. There's also a Git repository that Andres has been publishing that is updated more often than the email messages, and that's also linked from the commit fest entry. I did link that from the commit fest entry. I hope you didn't mind that.
Not at all.
So you can find that there. I guess we have sort of the mixed crowd here. I don't know, some people have probably already looked at it, or some people have no idea what this even is about. One more person joining. So maybe I'll do a quick sort of what is this even, and then we can get into the more details. So I mean, what Meson is, it basically takes the role of, let's say, autoconf and automake, right? So it's sort of both a tool that creates, let's call them make files, but they're not really make files. It creates make files from some sort of abstract description. But it also has the sort of compiler tests and things like that autoconf does. So that's the role of that tool. It doesn't actually replace make, because it just creates those files, and then other tools take over that role. And Meson supports multiple, what they call backends, to do that role. And make is not one of them, so we'll have to move on from make as well if we want to do that. The preferred tool for a sort of Unix system is called Ninja, which is essentially very similar to make. And then, you know, there's a sort of a description of here's a target, here's the prerequisites, here's how you build it. But it's, well, the point of Ninja is basically it's much faster than make. But Meson can also produce Windows sort of build projects, Visual Studio, whatever they call it, projects. And does it also support CMake output? Is that correct?
No, it supports also Xcode, which is like
Xcode,
the Apple
yeah. So you can build like iPhone projects and stuff like that. So not so relevant for us. So basically, it's Ninja or Visual something, which is.
I mean, the Xcode stuff is, I think, useful for people that want to use the GUI, because then it supports all the error like the highlighting of errors and all that stuff, and building from the UI, from what I understand. But I have never used it.
So that's kind of the broad description. Now the reason why, I guess, I was just looking at the notes from my old PGCon Unconference here I found in 2019, and notes. There was a session on build systems where it was talked about, you know, the current system is too cumbersome, too slow, blah, blah, blah. And we talked about a couple of different options, and I guess time has passed since then, and now we're looking at this as the best option. At least that's sort of the way I come from. I don't know, Andres can maybe give his thoughts on why he wants to do this.
My motivation was mainly that the builds are just too slow, and particularly on Windows, it takes forever. But also on Linux, like, I don't know, Ninja builds in like less than 1/10. Ninja on my machine builds quicker uncached than make build with CC cache fully primed, just as a baseline. And the second motivation was that the test runner, the to have a test runner that can run tests in parallel on all platforms, because right now the way we run tests with Make, like we afterwards, it's very hard to know which tests failed and to see or to run a specific subset of tests. And on Windows, we basically have no way to run all tests, and there's no test concurrency, and that leads to like tests on Windows just taking unusably long.
I'm
and
curious.
Mason had a test runner.
What's the difference between, were there any benefits with Meson like versus CMake, for example? Because CMake builds Ninja also.
Yeah,
I have
I
a
found
follow-up.
CMake
ugly. Sorry for interrupting. I have a follow-up question. Basically, I wanted to ask the same. I have a very weak recollections that a couple of years ago there was a patch by Yuri Zhuravlev who suggested to use CMake, and I'm not 100% sure why it was not accepted. It was something about compiling extensions, if I'm not mistaken. And I wonder how this patch differs from the previous one and why you, and if it addresses the same issues.
For like, the reason I didn't choose CMake is that I find CMake very hard to understand
Ugly.
comparatively, and the syntax is awful. And the second aspect was that a lot of projects had been migrating, like open source projects had been migrating to Mason, like QEMU, Mesa, and like just there seemed to be a momentum in the open source space towards Mason. So yeah, it seemed to be like something where it's more likely that people coming from other projects would already know, like in the open source world, that would know it. So it seemed good from that aspect. The reason why I didn't base my work on the CMake patch set was I looked at it and was considering it, and it didn't really seem all that complete to me. So it didn't seem to be a super helpful start. And I think from what I remember, like I reread that thread, and it mostly just didn't quite seem finished and looked like it needed a good chunk more work to be finished and like work on multiple platforms. And yeah, the extensions are an issue, and like I've some
open issue.
like
open issue extensions.
Yeah, I have like 3 different current prototypes for making extensions work. Maybe we can have that like a dedicated section later about what the best way forward with PGXS is. Yeah.
Yeah, if people want to, I can kind of show a quick demo just to people get a feeling for what this is and what it would look like, and we can kind of keep talking while that is running. I just gonna sort of try to share a shell window here. See if this works. If people,
one other
people
comment
can keep,
before we move on is that I remember
talking.
having looked at those CMake patches and felt that they lost a lot of the detail that we've accumulated in configure script over the years about portability to different systems. So it felt to me that was going to be a big step backwards. I don't know where we stand right now with the current patches on that point.
Yeah, that's also an open question, right? I mean, we went through this just recently, just make sure everything is sort of covered, but we will know. So people can see my screen here. So this is just the checkout of the branch that we just talked about. So everybody can try that. So Meson requires what we call or vpath build. So you have to have a separate build directories. You can't build in source. So for the 50% of us who do that anyway, this is not a change. For the 50% who haven't done that, this will be a change. But that's just the way it is. And I'm those 50% who usually don't do that, but I'm getting around to it. So you call Meson. Then the first command is called setup. Right. So it's there's actually also called a thing called Meson configure, which is not the same thing. That's a little weird difference, but setup. And then you specify the build directory. So I just use this one. And there's options here that we'll leave off now. You can set prefix and, you know, a bunch of options, but that's just a basic start. And then you can see this looks, you know, kind of, you could expect it checks for a bunch of things and has colors just because it has to be done that way, right? But you can turn that off if you don't want to. And you recognize a lot of that, right? The one kind of what I find a neat idea in Meson is by default, it tries to sort of enable as many options as possible. So if it finds Python or Perl or, you know, then it enables it. But also if you're a packager, you can disable that behavior. So these are called auto options. And then as a packager, you want like full control what you build with. You turn all the auto options off and then you just pick what you want. So I think that's kind of a neat sort of compromise, I guess. And at the end, it gives you a nice little output here of, you know, what you configured, what it found, options, what was enabled. You know, as you can see, it enabled a bunch of things that I didn't even specify just based on what it found. And then the next step to, as you can see at the bottom, they also found Ninja. If you want to then build, there's two ways to do that. One is you just change into the build directory and you call Ninja directly, or you can also write Meson compile. It basically just invokes Ninja.
You could do the same with Ninja directly. Also, Ninja-C would also work.
Or that way. So you can either call Ninja directly or Meson compile, but then of course that's more abstract. If you choose the visual something backend, then you don't have to change commands. But if you want to do like more detailed work, you know, Ninja also has a bunch of options similar to make. So as you can see here, it's kind of like all sort of in line here. I guess there's 1,900 something targets. Automatically parallel. You can hear my fan going here.
What happens if you get a compile error or something like that?
It'll print out, you'll see that in a moment here. Whatever these commands print out, it will print out because there'll be some junk being printed in a moment here.
And you can make it with -v. It will print out all the commands if you want.
Right.
I need that.
This doesn't actually seem drastically faster than what I'm used to. In fact, it seems slower.
Well, this is, yeah, I don't know if this is cached or what the situation is now. But it
seems slower than my machine.
Running. I guess this is also probably I have everything enabled here. I don't know if that makes a difference.
Half a second on my machine or a second on my laptop.
To build everything. So this is the junk output here that it prints.
Oh, interesting. I didn't see that on.
No, this is usually faster. I might have just like disabled the cache or blown it away or changed something here recently because I was just working on this the other day. But you can see our nemesis here at the end, the ECPG build is always the slowest.
Yes.
So, it's just hanging on. It's just hanging on that now. Okay. So, well, let's give it a try here. Let's just say we are just going to change one file here, right? Let's like actually change it so it's not cached or anything. And then let's see how fast it is. So, I mean, I don't know how fast the compiler here is or something, but I noticed the.
Oh, you built with optimizations. I think that's probably why it was.
Okay. So, but as you can tell, it doesn't have to growl through hundreds of subdirectories here or anything, and then just say nothing to do, nothing to do, nothing to do. It just knows everything immediately and just does like compile link and it's done, right?
I mean,
so that's really cool.
I mean, that was a lot less noisy than MIG was, but it wasn't significant. It didn't look significantly fast. I mean, maybe it was a little faster, but like whatever.
If you would do this with make, it would probably take like 5 seconds just to go through all these subdirectories. Well, I guess I'm not really representative of how fast things are here. But, so I guess the next thing here would be, I guess then there's also, I'm not going to do this now because it just takes a while. You can do that install, right? It's pretty straightforward. And I guess the test is kind of interesting. I'm not going to run the whole test now. I'm just going to start and then abort it after a little while. And so you get an idea of where things are. So I guess this is still a little bit under discussion of exactly how to do this, because the way this temp install thing works is very specific to Postgres. It's not really easy to reproduce, but so it did the temp install and now it's just running all the tests.
You could also like list the tests that you want to run with.
Right,
either.
there's ways to run like a specific test or a specific test suite, the way it's called, but by default it just runs all the tests there. And it supports tap test, regress, isolation test. You can see some of the progress. It runs multiple tests in parallel, you can see there. So
Andres, on your laptop, which I realize is like a Cray, how long does a cached build take?
A cache build, let me just check. I'm doing an uncache build, 1 second.
Because I just tried my usual invocation on my laptop here, which does use Ccache, and it built, make took 63 seconds with my usual degree of parallelism.
I had it set up so that it doesn't use the cache at all, CC cache explicitly.
So here's while they're figuring this out, you can see some of what Andres was talking about earlier, that it has sort of a global knowledge of all the tests that, obviously I aborted this here, so it's a little bit funny, but it gives you a complete sort of run of all the tests that will run and things like that. And then you can also, in the build directory, there's, besides the actual build, there's a bunch of subdirectories of logs and info and details of what tests were run and dependencies and all kinds of weird stuff you can dig into. So that information is all kept there.
Mm-hmm.
And you can list the tests with, like, if you just write bson test -- list, it'll list all of them, so you can choose which ones to run.
How does this interact with Ccache? Do you still use that or have the option to use that, or is it?
It automatically defaults to using Ccache, or you can, but you can disable that.
But
I mean, if it's available, it uses it.
It doesn't replace Ccache or anything like that.
No, it uses Ccache.
I guess one thing, maybe if you just want to see what these build description files looks like, there are meson.build files. You can see here, this one. So those are in every subdirectory. I guess the top level one has all the compiler tests. So maybe let's just look at the simple one here, maybe. Here.
By the way, Robert, a clean CC cache build is 4 seconds on my laptop.
Okay.
And nothing changed build is 0.062 seconds.
And how long does a Ccache build take with the current build system for you approximately? Is it like a minute, like it is for me?
24 seconds.
Okay.
Something.
Right.
Or let me just check. This is a test, the way it's set up right now, it will build everything. So not just like main, it also builds contraps and ECPG. So that might be relevant for the comparison.
Okay.
So this is the build description language here. As you can see, it has its own, this is not anything. This is not Python or anything. This is its own language. Meson is written in Python, so it's obviously inspired probably by Python most closely, but it's its own language, mini language. So, but it's pretty straightforward. You define list of files, targets, and variables, can do a little string concatenation in here. Then if you build a program, it looks kind of like that. And
Is what we're looking at here handwritten or is it generated somehow?
This is
no, this was handwritten.
I'm a little concerned about the fact that we seem to have hardwired knowledge, the appropriate flex switches into this, and the make files that's shared more globally, which seems like
Yeah, that's probably should probably be done. I've just
Yeah, that could be done. You can have variables like stuff like this here. That's almost the exact equivalent of what you're talking about, right? You would throw that into some kind of variable and throw that in here. So that would be okay.
Yeah, it also, I don't have, it's not yet implemented. We have that that checks that whatever the backup files that are generated, that error check isn't implemented. There's like a bunch of small cleanup steps, definitely not yet done like that. But like one of the advantages of not having the recursive nature of make is that dependencies work reliably. You don't have this issue that you're in some subdirectory or some binary changed and that you recompile and it errors out because like some headers haven't been generated or stuff like that. That we currently either have worked around with a lot of excessive recursive invocations or just by disabling parallelism in parts of the build.
Yeah, some stuff currently doesn't work at all. I remember if you change something in like FE utils, then nothing gets actually it rebuilds the library, but nothing is actually relinked to it. So it's kind of
I noticed
terrible.
I noticed that recently and was annoyed.
Yeah.
Yeah,
so
you need to build I just built twice now, everything, because I found that's the only reliable way to do it.
Yeah, so this is much better in that respect, definitely. So it's like, this is a little bit weird to understand in some way that even though every subdirectory has a Meson build file, they're all kind of merge into one namespace in a way. So they all know about each other. It's not like make where each make file is its own totally separate thing and it has a few include files, but otherwise it doesn't know anything about its upper level make files. This is all one. The fact that you have separate files is just kind of for sort of convenience in a way. But you can sort of much more easily have cross directory dependencies here because you just say like, well, this file over there. It doesn't matter what directory it's in.
If you wanted to build just a particular thing like in contrib, how would you do that? Or is it kind of the same way as when you use make?
You would say like, I don't know, Ninja, SSC bin, contrib.
You just go in here, right?
No, you have, it's the, you
have to be at the top.
There.
Yeah. See, this is it. Everything is sort of from the top level, right?
And the same with contrib, obviously. But
there's also a way to declare the sort of custom targets if you have some weird specific thing that you kind of want to call. There's also a way to sort of set separate targets that you can.
Yeah, if you type Ninja
directly.
backend, that is one of them, for example. Just did that. So that will build all the backend parts because I wanted to demonstrate having that. We could probably add like Ninja contrib.
So where do you define that? Your backend example?
If you open the top level Meson.build.
It's a top level one. Yeah, okay. It's somewhere. Backend.
And look, alias target, and that just is and that has just a list of the targets that are included, which is an array, and it just.
I guess this is sort of an example here. Right? It's just saying you can throw in more stuff if you want.
I like how it says the end, my friend, and then there's more stuff.
That's just the summary, the output of the summary of the configuration. So there's nothing that like changing anymore after that point. But yeah.
So if you wanted to see all the aliases that are available on Meson that you have predefined, is there like a help screen like Meson help or something?
Let me check. I don't know. whether there is.
Yes, all of that is available. I mean, in some cases, you have to kind of, I wouldn't know it off the top of my head now. Some of those things I've written down somewhere, of like listing all the targets, listing all the options, listing all the things like that. You know, it's all somewhere.
Was it tested for compatibility with Coverity and other static analyzers and CLOC, is it called, for code coverage testing and other tools?
I don't know what that last one is. Yes, it otherwise works well with enabling coverage, enabling what's it called? One of the sanitizers.
Yeah, sanitizer is. I mean, that's basically just a compiler flag, right? That, I mean, it has some support
Compiler
for
and
that,
linker, but yeah.
yeah, there's like some, you know, the sanitizer essentially just flags you pass, so that's easy. It has coverage support, but I found that to be dubious. I got dubious results from that, so I'll have to look into that again. And what else? I guess Coverity. How is that actually built?
I think that's
does
just
that kind of stuff-
using a different compiler binary, basically.
Okay.
I don't know. I haven't tried that. I think I wouldn't. I know that there's plenty projects using Coverity that use Mason. So
Right.
apparently,
Yeah,
isn't
you just pass a
huge
different
issue.
compiler, and then it still compiles and just keeps sort of extra data somewhere.
Why is the ECPG compile so slow? Has anybody ever looked into that?
Because the grammar is huge. It's like the whole SQL grammar plus the whole C grammar.
Well, why would it be slower than the core grammar, which is about as
Because
big?
it's just the SQL grammar, not the C grammar. And I think there's some quadratic type stuff somewhere in with the tables, somewhere in the optimizer in the C compiler, it seems. But if on my machine the whole build speed is limited by Bison speed, because Bison translating the main grammar is like it has like everything depends on that basically. So it's the slowest part, both for Bison and then compiling that output file.
Have you tried using this with LCOV yet? You know, GCOV,
With what?
LCOV? Have you tried using the coverage to generate coverage reports yet?
Yes, there's an option to enable it.
Okay, cool.
I'm actually running it, the tests to then do that in a second.
Okay, so it's a built-in thing to deal with.
Yeah, it's Mesa. You just if you run setup minus coverage.
Nice.
I'm a little bit suspicious about the results I'm getting from that, so there might need to be some refinement, but it's there in general.
Okay. I know this is a loaded question, but how far along would you say you are on this, you plural? You know, for like a full migration to Meson, including the extensions.
I think that I would get somewhere 85-ish percent. I think the biggest open items are figuring out I haven't gotten access to a Solaris machine that is not overloaded. I got OOM errors as soon as I started GCC on the one that I had access to. Similar on AX, I haven't, and like it's just the number of like less common platforms. That's one area that's not complete. Yep. Then there is like PGXS, like basically the whole story around that. And there's some, like I think on that list, a wiki or a GitHub issue, I listed a bunch of things that are just my current to-do list that one can check off. But like those two, I think like the remaining portability issues and the PGXS are the biggest things. So maybe we should just talk about PGXS, because portability stuff, I think, is mostly just elbow grease, I think.
Before we get into that, from what I've seen so far, there is no technical reason that we cannot continue to support the autoconf and make system parallel to this, at least for a while.
Yeah, the only thing is that if you build in tree with autoconf, that causes problems.
Yeah.
So I added a defense against that, so it doesn't allow to, like, it refuses to work if you did that, because like otherwise it just finds like the PG config of like the in-tree build.
Yeah.
But otherwise, like at the moment, the CI for it tests that the autoconf and existing Windows build system continue to work.
Right. Yeah. Obviously, there's going to be some transition period here, so I'm concerned that we have the ability to overlap that.
Yeah. There's some preparatory patches that affect both build systems that just basically adds new options to some of the Perl files and so on. But other than that, after that, it doesn't affect any common files.
There's a question. Are we, if we're going to overlap here, it's going to be a little bit painful for extension developers to say also maintain both. Have we given any thought to backpatching CMake so that you can have, sorry, I meant to say Meson. So you can have Meson for all the current versions if you're an extension developer and switch over?
Not at all realistic, unfortunately.
Okay.
I think that's actually, but that goes back to that PGXS question, basically. So maybe, unless you had anything else, Tom?
No, I just want to clarify that.
There, I think I can think of like 3 approaches there, basically. One is we just require that you write some Meson, and it will just be basically a native Meson file, and that will work on all platforms. The other approach is that we just generate whatever the makefile.custom, makefile.global.in. We can just have Meson just generate that, and then PGXS just continues to work as it is today. That basically, I tested that works. Obviously, that's not a great long time approach because that requires us to maintain some of the make infrastructure that we otherwise don't need and don't trivially have in-core coverage for. And the third approach I've prototyped is to basically have PGXS with the existing makefile syntax, and then have that automatically generate Meson file, and then build have make.
You want to parse the make file and create a Meson file out of that?
But it's basically what I've prototyped, yes. And it does do simple content files, content models, because PGXS make files aren't all that, they're fairly regimented, right? It won't work if you have lots of custom rules or anything, but the basic PGXS stuff works. I don't know whether that those are just the 3 things that I could come up with.
I think 1 and 2 are fine. I mean, I would just do 1, but if 2 is already available, then I think that would be also good for a while.
I mean, 2 was basically 5 lines. So
yeah, I mean, it's not that hard, right?
Yeah, I think, if we provide overlap, we can just say to developers, well, sometime in the next 2 years, you need to write a Meson.build file. That seems to me to be perfectly reasonable.
I would like to point out that there are extensions that are using CMake already or are written in languages other than C, and they're written in Rust and they're using their own.
But those won't be affected. If they don't use any Postgres infrastructure for building the extension, which they can't because Postgres doesn't provide infrastructure for building Rust or whatever extensions, then they just probably just use PGConfig to get the compile flags. And then
they just use PGConfig. Like the CMake ones extensions I know of, they all use PGConfig directly.
I'm not saying this is not going to work. I'm saying if we care about extension developers, we better check that they will not suffer more than they usually do.
Yeah, I just mean that I don't see how they would be affected, basically.
As an example, timescale is written, it uses CMake and just saying that, okay, you have to migrate everything to
It's like-
Meson.
They don't.
You don't need to touch it. It will just continue to work.
Call again?
It will just continue to work. They don't need to do anything. If they don't use the PGXS, then they're not affected by the change.
Okay.
So, like, yeah, shouldn't matter for what we do for anyone that doesn't use PGXS.
I'm just thinking if I'm an extension developer, which I am, and I've got an extension that I'm compiling for all the current versions of Postgres.
Yeah.
So now I'm going to need the make file that I already have, plus Meson, and keep those up to date with each other for the period of, the 5 versions of Postgres being current. They're both going to have to work until version 16 is released, or 17, depending on when this goes in. Because I'm not using just the make file to build against older versions of Postgres. I'm using, I've got one code base for my extension, which builds against multiple versions of Postgres. That's the way most extensions work. So I just need to keep those up to date the entire time. And I was just wondering, I'm not saying that's the wrong solution. I'm just wondering, if there's something we could do in core to make that less painful for like every extension developer out there.
I mean, that's what
my
first proposal, like the first thing where we're suggesting that we just generate the make file global and then install the PGXS make files. Then you could just build with make as you did before. It will not provide you with Windows MSVC
right.
stuff because that doesn't work.
I'm thinking of more non-trivial
already, right?
Like say PostGIS, which probably has a pretty complicated make file, and we'll need a pretty complicated Meson file too. And those will be maintained together for the number of versions that PostGIS is going to support, number of versions of Postgres. So it's not.
I mean, from our point, from the PostGIS side, PGXX has always been a pain, because it interacts with the dependencies that we have. And so sometimes it overrides things we don't want it to override. So we were actually thinking of getting rid of PGXS
and rolling your own.
And like if you roll, like depending on how we do the Meson based stuff, it might also be that it might actually also work against older versions. I haven't actually.
Yeah, that's what I was just thinking. I mean, if let's say you have an extension and you just write a Meson file, there's no reason why that wouldn't work against an older version. Because presumably all you do is somehow call PGConfig to get some directory information, and then that's it. So it doesn't
depends
actually
a bit on how short you want.
Oh, I see.
But,
I mean, it depends on a lot of the details, right? But there's no. But I think having some sort of a transition there, if as was described, sort of have the PGXS makefile be generated.
Yeah, if I could do like a hard
feasible,
cut.
it sounds like we can keep that around for a couple of years. And
yeah, if I can do a hard cut over to Meson and then still compile back against version 10, although I guess we don't care about 10, it'd be 11, then that would be great, because then I could just make a hard cut to Meson. It builds on all the current versions of Postgres using pgconfig. That seems like a pretty awesome solution to me, and I get a better build system out of it. So
and you get Windows support. Possibly.
And Windows support.
Oh, wait, I don't get it. Why would it be okay for you to make a hard cutover?
Because if the Meson solution they're talking about is just going to use pgconfig, I mean, that's something I already do without needing PGXS or any of the Postgres infrastructure.
The problem with that would be that your Meson, like you can definitely do that, and like there's no problem with doing that today, basically, but it will be a bit more verbose than if we provide, like, we could install additional files that make it a lot less verbose to write some extensions, like, so you don't need to care about pgconfig and so on. So I think that's the terseness. If you want to be terser, then we probably need to provide some helpers for that, like just like before Mike, we had PGXS, right? That's, I think, the only
I mean,
Ask a query.
I would almost argue. I mean, I see what you're saying. I would almost argue against doing that kind of stuff if we can avoid it, because then we just have to kind of maintain that kind of stuff forever again, right? But maybe that's a detail we can kind of see in specifics.
I mean, I
Yeah.
thought Anders' this idea of providing something that could build a Meson file from a make file sounded kind of nice, because if you have an extension maintainer who doesn't know very much about Mason, or who they could potentially use that to do the port, right, and then adjust it as required, or they could just leave it in that mode sort of more or less indefinitely and be like, okay, so I don't it's not really urgent for me to update this. I can do it someday when the old build system goes away. Like, I don't know. Like, I feel like we shouldn't necessarily go too far in the direction of conveniencing ourselves in terms of what we have to maintain at the expense of inconveniencing all of the extension authors out there. Like, it's going to be a nuisance for us to all learn a new build system and figure out how to do the things that we know how to do now. But there's a relatively small group of people who are doing intensive PostgreSQL development, and those, for a decent number of those people, they spend many hours a week on it. So whatever, it's worth the effort. But like, why do we want to spread that pain, more broadly across the whole ecosystem? I feel like that's
it seems, I think I'm inclined to agree there. I think it's one thing. I don't think we can make that approach work for something like PostGS, because it's like basically its own build system on top of PGXS, and that ending up with the weaknesses of everything to combine together. And like there's no realistic way of us like converting that. But if it's like the typical simple extension that is just like, I don't know, the 10-line PGXS stanza plus like the 3 file names and an object obvious line and whatever module _ big, that is pretty easy. I don't know. I don't know whether
I just feel like if I were an extension maintainer, right, and I have done a little bit of that, for EDB proprietary stuff, but like whether it's that or some open source extension or whatever, like, yeah, if you have that case where you have like a something with 3 object files and it builds a .so and it's got a couple of tests and a .sql file, like if I were that person and I were not involved in the development of the core server, and somebody went and ripped the build system out from under me and was like, yeah, figure out how to write a Mason file, I'd be like, come on, people, like, why are you doing this to me?
But I think the proposal has been that I think we're sort of almost settling on that we will generate a PGXS make file, continue to do that. That would satisfy all existing extensions.
That was we actually agreed on. That's why.
No, well, I'm strongly proposing that.
Okay.
Given that it should be it sounds like it's pretty easy to do.
The direction of building a Meson file from a PGXS make file sounds more reasonable to me. That means you don't have to learn anything until you've got the time for it.
But that's the same with the generation of the PGXS. If you just continue to generate the PGXS file, like or makefile.global from makefile.global.in without as part of the Mason build and install the PGXS files, then there's just nothing that will change.
Sounds
then you don't have to change anything.
Yeah.
It does mean that we have to continue to maintain whether makefile.shlib and all that stuff, which is not, I don't know, necessarily fun. But outside of that, for the period where we maintain both anyway, it doesn't.
Well, the problem is the other way around is only a partial solution. This way around is, it should, if we do it correctly, it should cover all extensions that use PGXS. If we do it the other way around, you're trying to parse a make file and generate a Meson file, that will cover 45% of cases, and then you still have to do something for the other 55%.
True.
On the other hand, we have the problem that the PGXS approach basically means that we have to maintain those make files indefinitely, and there's a fair amount of portability stuff in there that does
Yeah.
It's
Okay.
not
Well,
going to be
we'll,
taken.
we'll have to see how
That's-
bad it is. Yeah.
I mean, just to state my position on this, I think either of those things is a strategy. I think for me, we sort of enumerated three options at the beginning, and I think the middle one was basically we'll just tell people they have to learn Meson and figure it out. And that approach I don't like. I think the approach of maintaining some amount of backward compatibility stuff in the makefile seems okay to me. I think having a translator seems okay to me. Potentially, we could do both of them for various periods of time. I think the thing that is makes me most think that the translator approach might be good is that I'm not sure that people are actually going to be willing to do the work to maintain backward compatibility stuff for the makefile for a helpful period of time, right? Like if I thought that as a project we were going to be committed, to keeping those makefiles working for, let's say, 5 years, I think that would be real nice, because then people have a long time to migrate, and not everybody updates their extension every month or even every year, but if we're going to be like, we're going to put the thing in place, and then in 12 or 18 months, people are going to be like, well, let's rip this thing out. Well, then maintaining the backward compatibility is barely even helpful. Better to give them the translator and give them a hard push toward the new system than to make them think that you're going to continue to support them and then, pull the rug out from under them almost immediately.
I think 5 years is basically free for maintaining those makefiles, because for that long we have the back branches anyway, and if you fix a portability issue in 14, 15, whatever, also doing that, applying that change to the makefile.global and makefile.sh, that doesn't change anything effort-wise. Meaningful. It's but 5+ years is, I think, the question where it starts to be different.
So in some way, I'm now also coming around to that this translator, if it can be made to work, would actually be kind of nice, because then you get Windows build support for a bunch of extensions that currently don't have it, and that's something people
the way
ask
I was
for.
imagining it would not necessarily do that, because it would still it would be invoked by make, is what I had imagined. It was just that the PGXS makefile would basically invoke the translator on itself and then just do everything. That was how I imagined it, but we can obviously.
I was imagining the translator as like a utility. I don't know.
Okay, I was.
Yeah, I was thinking of it as a utility too.
Well, at least there's an easier path. I mean, how automatic it is something we'll see, but at least there would be a path of here's a Meson file, whether it's a one-time thing or you can. But then
it could be both, right? Like it could be
yeah.
available for you to run, but if you just make use PGXS equals 1, that could trigger it. I mean, you're still going to break things for a lot of people. Like anything that doesn't involve keeping the makefiles working is going to break things for a lot of people, because, I mean, not everybody is going to have Ninja installed. Not everybody has Make installed, right? And there's going to be more people who have Make installed than have Ninja installed. I have to believe, at least. It may be getting more widespread, but Make is a 50-year-old tool or something ridiculous. There's going to be people who have to adjust stuff when we make this change, and it's going to be a lot of people, and it's going to be painful for those people. And if I were the me of 5 or 10 years ago, I'd probably be arguing that this is a dumb idea, because why are we inconveniencing all those people? And I still sort of do feel that way, but I'm a little more chill about it, so I'm not going to argue too much. But I do think we're imposing a cost on a lot of people.
Yeah, well, that suggests that we may need to keep the makefile system going for like 5 years or so. Keep in mind that we're maintaining 2 build systems right now. The thing that I would like to get rid of ASAP is the separate Windows build system. Yeah. If we could toss that overboard.
Yeah, that would be great.
I don't think there's any need to keep that around. It's not like you can't build extensions with it, so that whole thing is going out of. There's no equivalent to that. It has no testing support. There's so many holes in it that I think I would basically propose to drop it after a few months. Not.
Yeah, I mean, if I have to maintain 2 build systems for a few years, it's not worse than what I'm doing now. Yeah, and it's better, in fact, because there are two systems that I could actually run on a machine that I want
Yeah.
to use.
Yeah. 100%.
So
I think
I'm okay with saying, well, we got to support the make files for several releases. Yeah.
I think
Well,
the
the
question is
one
what
way
the
forward
order
is that we. Oh, go ahead, please. Sorry.
like it seems to be what you can say is we introduce Mason without any extensions support. I think that's a bit unconvincing. The easiest way to get extension support, and if we have to support PGXS anyway, is to do that, generate the PGXS files and just live with that. But then we need at some point a transition later on. But that seems like the easiest approach because we
I don't think that I believe that you need extension support for a minimum viable commit. I mean, if the idea is we're going to put in Mason and we're going to take out the existing Windows build stuff, and then at some point later, we're going to cut over from using Make for Linux builds to using Ninja, the problem with extension building has to be solved before that cutover thing can be solved. But I don't think that it has to be solved before you can start committing patches. I mean, I don't, if the initial goal is to get rid of the Windows build system, then I think the bar for the patch ought to be exactly that. It is good enough to replace the Windows build system, and that it is, enough of an improvement in some way, to justify the exercise of a commitment, right? Either in build speed or build stability or whatever, right? Like if we can get extension support out of it, that's great. And I'm certainly not, inclined to discourage you from doing that work. But the way that I view our procedures around committing, if it's better, it's better,
I'm happy with that too.
Yeah, I mean, one thing that's unclear to me, so this is just going to be from PG16 on. We're not going to, so other Postgres versions can't use the Mason build system.
Correct.
Okay.
It might be that we can, you could obviously just for, I don't know, PostGS can just convert it to Mason and use whatever PGConfig to get the necessary flags, and then that will just work across all Postgres versions because there's nothing connected to Postgres. There's no dependency of the build system to Postgres' build system. And that's how a bunch of extensions work.
Mm-hmm.
So, but it's the in-core part, backpatching, that is.
Okay.
It's way too
I mean,
big.
I'd be happy to test that on the Postgres side, just because the PGXS is a pain anyway. If you're committed to moving to Mason.
I'm just about to start working on a new extension and switching PG Backrest over to Mason. So I'd certainly be willing to try that out. Just, from the get-go, just build the extension off of PG config and, not have any real dependency on either.
It really is not a big problem. I've done that for local extensions to test it out.
It's really not. I mean,
one thing that would be interesting.
Yeah.
Go ahead.
I was just saying we obviously link against libepq now, and we use PG config for that. It works great. So, I mean, it's pretty similar.
Yeah, one thing that the shortest way to build, or the tersest way to build something like I don't know, a shared extension library with Mason without any Postgres infrastructure is to rely on PKG config files that Postgres installs. We don't do that currently for the main binary, but if we were,
we should do that. Maybe that might actually solve a lot of problems.
I've played with that. That makes if you do that, then something like a shared module, like a server extension library, is really easy to build.
Yeah,
because that's where it can get all the flags from without needing to know the various things from PGConfig and so on.
Right. I think that sounds promising. We'll have to see the details, but
and that's actually something that we could consider backpatching because like we already generate a bunch of PGKG config file, but not for the server.
Right.
And if you like adding one more PGKG config file seems a lot more realistic than backpatching a build system.
Mm-hmm.
That's
Cool.
probably a good idea to have a migration guide
Yeah, it
during
sounds
the
like-
transition that shows how you used to do it and how you're going to do it now, and then best practice for doing stuff like extensions.
Yeah, I think that would be really nice to have, you know, at least as a developer README, possibly as a part of the HTML documentation, or could be, you know, a web
Like, it
page
has to be, I think,
someplace
yeah.
or something on the wiki. But like, it would be, I think it would be really, you know, there's two things. Like, it'd be nice, really nice to have something that the extension authors could read, and it has to be someplace where they're naturally going to be likely to find it when they start to run into problems. Like, there could be a little like thing I don't know, there could be a thing someplace that people might find it that says, here's where to go to look to tell you how to adapt to the new system. And even if it just explains, you know, how to adapt the simple cases, then at least people aren't sitting there struggling, because that's the worst, when you like, when something stops working and you don't know where to go to start looking to figure out what you're supposed to do about it.
Yeah, but like Peter's build showed, it was basically enable all the extension stuff by default, which is different from what we have now.
Yeah. I mean,
So how do you turn that off and just basic stuff like that, so people can sort of get an idea of how to change their compile setup.
Well,
or
that's a
whatever
different,
it's worth, if you don't want that auto enable flag, that's just whatever we set as the default for those options. We can change that default to be disabled, and that's that. Then it will work just as now. I found it to be useful for development purposes to have it set to auto, but that's a policy.
Yeah, that was
for
actually quite nice,
Mason.
because I had failed to enable in my local scripts when the what is it called, Z standard stuff was added. I just never enabled that, so I never actually tested that, and you know, that kind of stuff is this
But
way
yeah,
it's
I think
turned on automatically.
we should have like one of those, I don't know, tables that says left, here's how you used to do it, right, here's how you can do it with Mason and Ninja. That should be quite doable.
One thing I would like to ask, and I realize it has little to do with Meson per se, but it bothers me very much. So from what I know, when Perl was chosen for tab tests, it was argued that Perl is available out of the box for the most supported platforms, and thus it's more preferable than Python. But Meson is written in Python, and in this case, community considers it's okay. So I'm trying to get the understanding of the exact philosophy in terms of choosing a particular scripting language. Is it about what is most practical in given case, or how exactly does it work?
Well, you just gotta sort of, you make the decisions at the time, right? It doesn't necessarily need to be consistent for all eternity.
yeah,
Yeah,
I mean,
I think if, you know, if we're switching over to Meson, that will certainly affect the decision of whether Python infrastructure is okay. There won't be a reason to say. Up to now, you know, Perl was just what we have been using, and we didn't want to add another build dependency.
I mean, when we started using Perl, I remember this, we were still supporting Perl 4, right? So that's, I don't,
It goes way back, yeah.
Python even existed at the time yet, really, or just barely. So,
Yeah, I think at the time it was the only serious option. If we were making that decision afresh today, I don't know that it would be the choice, but
Yeah, I think we'll have to at some point contend with the problem that Perl is getting less and less maintained, and like all the modules we use are basically unmaintained or or officially unmaintained. Like IPC run is not maintained anymore. Test more is not maintained anymore. Like it's, and you notice it because like there's just bugs that have not been fixed for years, and or open bug fixes that don't get applied, and That will
The
become
thing that kind of sucks is that, like, if we started supporting tap tests written in Python, okay, well, I'm gonna have to learn more Python than I know right now, but all right. But like, if we decided we really wanted to get off of the Perl tap test,
Yes.
that is a crap ton of stuff to rewrite. But if you don't, then you never really get out from under the kinds of problems that you're talking about, you know? Because like at least right now, because we've got all of our tap tests on one system, you know, maybe it's not being maintained upstream very well, but we're pretty motivated to keep like our little bit working because our build form is dependent on it and everything. And if you got into a situation where, you know, people started writing new tests on a new language, and then here and there something gets migrated here and there, I'm afraid you'd end up with a situation where, you know, our own tests, some of our own tests were in this sort of semi-unmaintained state, which seems like it might kind of suck. But I don't really know what the way around that is either.
Yeah, we're sort of victims of our own success here because we keep outliving our infrastructure. This is not the first time we've had a discussion like this.
And can we talk about Bison while we're talking about and Flex while we're talking about outliving our infrastructure?
Yeah, well, got something better?
Nope.
No, I was sort of encouraged that things seem to be happening around Bison again. We'll see if that goes anywhere, but there are apparently people working on it.
Just to go back a tiny bit, Peter, you were mentioning coverage. I just changed the coverage. It looks nearly the same as the existing coverage report, except that it adds like a branches column and that the ECPG tests aren't run. So like the coverage of ECPG is 0, but that's because we didn't finish.
It is quite possible that this is maybe a macOS specific problem or something like that. It was very weird. I assume if they have that option, it would work because it's not all that difficult, but we'll have to dig into that a little bit.
Yeah, it supports like 3 different tools for generating the coverage. So it might be that there was some, like it supports LCOV and GCOV-R, which I had never heard before, but for generating the different formats of it. So I don't know, maybe it was one of the other, you hadn't all the tools installed or something. I don't know. I just know that it works here. I can test it actually I got an M1 because I was too desperate trying to figure out all the weird macOS issues without having access.
So I think we're out of time in this slot. I took some notes here. I mean, I guess most of this discussion is going to end up on the mailing list. At least that's what I would encourage. But yeah. I mean, there were some discussions here about starting a wiki page with some sort of transition guides and stuff like that. We could certainly do that, but I guess we'll put that on the mailing list and figure out what people want to do.
I think it's better in tree.
Yeah, what I was thinking before was to add just a separate README file for the branch for now, that it has that, and then move so that it's immediately visible, and then move that into the HTML docs if it gets closer to commit. I don't think it makes sense to right now do that effort just because there's a fair bit of overhead in writing that HTML stuff.
I can help review that.
Cool.
Anyway, based on this discussion, it seems like the bar for how good the Meson stuff has to be to commit is a lot lower in my mind than it was at the start of the hour. We could put it in, and if we're saying we're going to keep maintaining the makefile side of things for a good long time, then the Meson stuff can be put in as soon as it works at all, and people can chip away at improving it. People will gradually start moving over to it if it's better than the makefiles.
If it does everything,
sort of an organic process.
Yeah, for just note on the maintaining the makefile stuff. I don't think we would have to maintain all the makefile stuff, right? We wouldn't. It would just have to be whatever the SSC makefile and SSC makefile.global.in and.
Well, I'll tell you where my bottom line is on that. You can't break a build farm member that is running the old build method. So whatever that involves, we have to keep going.
But like for 5 years or for the foreseeable future? What I think
no, cutoff point is fine.
Okay.
Based on this discussion, it would be when on Meson capable branches go out of support, we would say, okay, it's time, people.
Oh, I was actually thinking that we would potentially say that we only support PGXS necessary makefiles at some point, but require switching over build farm animals.
Yeah, I mean, the build farm animals could probably be on a shorter leash, like 2 or 3 years. But
because
I wouldn't necessarily see people trying to switch them immediately.
Oh, no.
The build farms, would they be testing both or just one? Like they'd still be set to either test the old system or the new system?
Probably any given animal would just run one. I mean, we'd almost certainly want to set up some animals running the new system as quickly as we could.
Yeah.
But if you want to leave one running the old one,
it's the same way now, right? Some systems run, Visual Studio, and others run GCC.
Yeah. If you look at the
pick it up,
Windows,
pick what you want at the
build
time
farm
you set it up.
animals or so. Well,
cool.
All right. Well, I guess we should head into the break and go to the next session. I'll try to post some of these notes, and then we'll continue the rest of the discussion on the mailing list.
Cool.
Thanks.
Thank you.
Sounds good. Thank you.
Thank you.
Thanks.